Hi everybody, Mr. Tannen here. Just going to make a quick video to go over problems 7 through 10. Why did I do this now? That's okay. Alright, thank you. So, this first one, which is talking about the cosecant function. If we have 1 over cosecant, be reminded that cosecant is the reciprocal of sine. So, 1 over sine x. Instead, you could think of it as 1 times the reciprocal. Rather than dividing by that, you could multiply by the reciprocal, so that's just sine x. Now I see sine squared x plus cos squared x, that's just 1 based on one of my trig identities. So it's the reciprocal of tan x, which is cotan x. This next one's a bit trickier for me, but if I remember correctly, I can take my sine squared x plus cos squared x equals 1, and if I divided everything by sine x, sine squared x I should say, I got this other identity which involves 2 of these. This gives me 1, this gives me cotangent squared x, and this gives me cosecant squared x. So if I subtract the cosecant over and subtract the 1 over, I would just get cotangent squared x minus cosecant squared x equals -1. So that means that equals -1. The last one on this problem, 7D, if we see here, I think I could maybe think about how to rearrange these in different ways as well. Well, sine squared x, if I were to subtract the sine squared x from my original format, 1 minus sine squared x is just cos squared x. Sorry, I'm just making a quick video. Is that okay? Oh, thank you. And if I remember correctly, one of my other trig identities was this one, tan squared x plus 1 equals secant squared x. So that means this could just be secant squared x, and watch how nice this is. This is the reciprocal of cosine, so this just equals 1. How about that? Wow. Okay, so number 8 was actually very similar to what I talked about during class, that if you divide everything, you actually get, if I divide everything by sine, I would get this identity. That's what I notice. And if I divide everything by that, I get this identity. How about that? Not too bad. Now number 9 is asking about simplifying this expression. Okay, well look right above here. Secant squared x minus 1 is equivalent to tan squared x over secant squared x plus 1 minus sine squared x. Wow, this is a wild looking one, but let's see if what we can do. Well, I know tan squared x is equivalent to, let's rewrite that as sine squared x over cos squared x, and I'm dividing that by secant squared x, which is 1 over cos squared x. So instead of dividing, I could think about that as multiplying by the reciprocal, and then that's just going to give me this cancellation. Bang, bang. So all of this simplifies just down to sine squared x plus 1 minus sine squared x. OMG, look, those cancel, so all of this just equals 1. How elegant is that? And lastly, on this one, for this last problem, number 10, it asks you to use this diagram to answer the following questions. And they are telling us that angle ADB is theta. And so, which segment represents the cosecant of theta? This one, I didn't love this problem as much, but if you remember when we were talking about this, when we were talking about theta, we had this diagram from the other day. DC actually represents cosecant, or CD, whichever you prefer. What's now a little bit interesting though is we know the cosecant of theta, you can see the length of this value is 2, right? So if the cosecant of theta is equal to 2, well, cosecant's the reciprocal of sine, so that means the sine of theta is the reciprocal of that, or 1/2. Think about what angle this would be. Well, I'm pretty sure it's a 30-degree angle as the sine of 1/2. So theta equals 30 degrees, or pi over 6 radians. Now the last thing here is to find AB. And if I look over here, AB, that value corresponds to the tangent. So we're essentially looking for the tangent of 30 degrees. Tangent is equal to sine over cosine. So this would just be 1/2 over root 3 over 2, which simplifies to 1 over root 3, which simplifies, if I multiply the top and bottom by root 3, to root 3 over 3. So the length of AB in this case would actually be root 3 over 3. And we know that because the tangent of 30 degrees corresponds to that value, which is root 3 over 3. Again, this one is, I really needed this up here as reference. However, there's other ways to do these, so if you did them other ways, I'm curious to hear in class. Let me scroll back up, but these are kind of fun. It may be helpful when working through these in the future, these type of problems, to have a list of our identities available as you dive in. Have a great day, and thank you. Mr. Tannen signing off.